All right, everybody, Hugo Bowne-Anderson here from Outerbounds. I'm so excited to be here with my dear friend and colleague from way back, Hamel Husain, a machine learning engineer who loves building data science and developer tools, formerly at Github, Airbnb, Outerbounds. We're here to talk about natural language processing, meeting MLOps. And we'll get started in a few minutes. What I'd like you to do in the meantime is introduce yourself in the chat. Let us know your interest in these types of things. Are you an ML engineer or a data scientist or an executive who's interested in building these types of things and incorporating machine learning into their business? So say hi, let us know who you are, and we'll get started in a few minutes. Hi, everyone. Hugo Bowne-Anderson here from Outerbounds. Very excited to be here today with Hamel Husain to talk about natural language processing, meeting MLOps in the infrastructure stack. We'll be doing a live code along today, and we'll get you set up very easily with our Metaflow Sandboxes to this end, and I'll share a link there in a second. But we'll get started in a minute or two. If in the meantime, you could introduce yourself in the chat. Let us know who you are, where you're dialing in from, and your interest in this type of stuff. That would be awesome. All right, we'll be starting very soon. All right, everyone. Let's jump in. Hamel, why don't you and I turn our cameras on and get started?
All right.
Whoa. Yep, and Hugo's starting video now. All right. Hey there, Hamel.
Hi.
How are you, man?
I'm good. How are you?
I'm good, man. And I was going to say it's been a while since we've spoken. I mean, that's not true privately, but it's been a while since we've spoken publicly. So it's great to be doing something with you again.
Yeah, likewise.
And just to let everyone know once again, and we have Daniel McGee here, who's in Los Angeles, analytics data science manager, Sol Avale from Colombia, and Eddie from Outerbounds is in the chat as well.
Hi, Eddie.
So we've, as I said, a brief introduction is you're a machine learning engineer and you love building data science and developer tools. You've been at GitHub, Airbnb, Outerbounds. Do you want to say a few things about what you're interested in at the moment, or anything I've left out about your background that you'd like to let people know?
Yeah, that pretty much covers it. Yeah, you've covered like what I've been doing. I'm building developer tools. More generally, I'm working on NBDev, which is an open source project for literate programming and exploratory programming. And yeah, I'm kind of doing that at the moment.
Amazing.
And yeah, I really like Metaflow. I'm gonna tell you why.
Fantastic. Cannot wait. And if people, I mean, you work on such cool stuff. If people are interested, they can connect you on LinkedIn or follow you on Twitter or something like that. Hamel Husain is pretty easy to find on both.
Yeah, you can just Google my name, Hamel Husain, and it's a pretty unique set of characters, I guess, on search engine, so it'll find me.
Absolutely. So we're here today to kind of do a live code along, and everyone will be able to code along. I'll provide a link in a second about how all of us as single data scientists or ML engineers can build, train, test, and deploy ML models that perform text classification using Metaflow, but it's generalizable there. And the goal is to build a pipeline with industry grade open source tools such as Tensorflow, Scikit-learn, Metaflow, these types of things, and you'll be able to code along directly from your browser. And look, I'm going to share my screen and show the sandbox in a second, but I'm just going to provide a link to it now. I am so excited, and this is essentially look, I'll say 20 seconds on it now. Getting set up to use the entire ML infrastructure stack is highly non-trivial. And so we wanted people to get up and running with testing Metaflow, doing these types of projects immediately. So we've essentially got a browser-based souped up version of VS Code that gives you access to all the data, compute, versioning, orchestration tools, that type of stuff. I'll go through that a bit more in a second, but that's the tool we'll be using. So you'll be able to code along with anything you want, essentially. I also want to say, you know, if you like the sandbox or want to ask questions about it, I've just posted the link to our Metaflow community Slack in the YouTube chat. So come and say hi. If there are things that excite you or frustrate you, you know, we're always open to chatting and love chatting about that type of thing. The one other thing worth mentioning is I'm actually, you know, super humbled that you're all here, particularly because we're not talking explicitly about LLMs today, right? So it's nice that people will turn up to something which doesn't involve LLMs at a time like this. Of course, there's a huge appetite for things not LLM involved, but I would definitely need to fire myself if I didn't tell you we do have an event coming up about LLMs and thinking through how to develop and build sustainable business value and defensible moats with LLMs, and how to incorporate. We've got a lot of proofs of concept with LLMs. It's not clear how to incorporate them into robust pre-existing software stacks. So we've got an event coming up about that. And once again, I'm just too excited about all of this stuff. Just now, I mean, in the past couple of hours, we've published 2 blog posts, which I really love about LLMs and the infrastructure stack. So I'm going to link to those as well in the chat. Feel free to check them out and come and chat with us on Slack about them as well. I presume most of you know what we do at Outerbounds, but we work on, it's probably obvious by now, infrastructure and productivity tools for data scientists that allow them to focus on building models and doing science while having easy access to infrastructural layers such as compute, orchestration, versioning, and so on. We do this through the open source framework Metaflow and an enterprise platform as well. So all of these things, you can probably tell I'm super excited about. I'm channeling the excitement of the entire team here. But that's just a bit of context on us. And without further ado, Hamel, let's jump in. And I think for the first 10 minutes or so, I wanted to give an introduction to the sandbox. And you can ask me questions throughout. I'll share my screen, and then we'll flip it, and we'll go through the NLP meeting MLOps, and you'll share your screen, and I'll ask you questions about everything you're doing there. Does that sound good?
Great. Yeah.
And while I'm sharing my screen, also maybe you want to give a plug. They'll put stuff online, but you just told me you're flying to Paris in a few weeks to give a talk at JupyterCon. Is that right?
Yeah. I'm going to be doing a tutorial on NBDev and Quarto at JupyterCon with Wasim, my colleague. So
amazing.
NBDev is a really exciting project. Check it out if you haven't already.
Definitely. And Quarto's a really exciting project as well, coming out of, JJ Allaire, the wonderful mind of JJ Allaire, and the company formerly known as RStudio, aka Posit.
Yes.
Very cool. And in fact, I am using Quarto myself. I'm writing a book with my colleague Eric Ma on Bayesian inference for Pearson, and we're using Quarto to generate all the LaTeX and PDF from GitHub, etc. It's actually really cool and intuitive. So I'm going to post the link to the Sandbox in the chat again, and we're going to jump in. So this is our Sandbox page, which, as I said, allows you access to. Can you see my screen, Hamel?
Yeah.
Yep, you can see Chrome, and allows you access to all these layers of the stack, and allows us to focus on the top layers of the stack as data scientists, all the modeling stuff. And you can go and play around with, the welcome, the tutorial, some foundation model stuff, the NLP one, which we'll get into later. I'm going to just jump, for 10 minutes into the welcome, and then Hamel, as I said, is going to jump into the NLP.
Can I say something about the Sandbox, if you don't mind?
Yeah, I would love that, man. Talk to me.
So Outerbound, if you go to outerbound.com, this is where you can go to get a lot of help on Metaflow. And,
yes.
Just, what Metaflow is and how to use it. There's like these really good resources for data scientists. And the thing that's really cool is, like a lot of times you go to some website like Docs and you look at tools and they give you a lot of examples and stuff. And it's really hard, like to get started is really hard. You have to install this stuff, you have to do all this stuff. And I always wanted, one of my dreams is to be able to run all this code in the browser somehow. Like you see some docs, just run it. And I think like this is really cool that like Outerbounds has kind of tried to take it to its limit in the sense of, hey, like most of these examples that are shown, you can actually run it in the browser. And, they have this Sandbox thing. You can click on any documentation and you can try it out really quickly. And that's like really cool way. Like it really allows you to like learn things really fast or try things out when you're looking at it in the docs. So it's like actually really good documentation in that sense. It's like taking documentation to the next level with Outerbounds. And I think, that is like one of the reasons that you might want to use Outerbounds or Metaflow is because of that. Because I don't know of any, I'm not really sure I know about any other tool on top of my head that you can just quickly just try it in the browser. It's a pretty magical thing. What do you think?
I really appreciate that context and totally agree. And that was part of our, as you mentioned, rationale behind doing this. Let's say it's not obvious. Look at recommender systems. A lot of the, production grade knowledge and infrastructure around recommender systems is siloed in organizations. Now, friends and colleagues of ours, such as Jacopo Tagliabue, have open sourced a lot of the code. But how do you get set up with the infrastructure? It's still, and learn how to do it outside an organization, totally unclear. So we can have, tutorials online with the code, but still that doesn't tell you, it can take you weeks to actually set it all up yourself, right? So as Hamel pointed out, we do our best to have all of these things available in sandboxes. And as we'll see, that will allow you to run all of this code immediately in your browser to get an understanding of how, so getting access to a Kubernetes cluster, which we'll see in this sandbox. So I totally agree, man. And to say a bit more about that, this is a wonderful little animation that my colleagues created about what a data scientist does. And as we know, their job is to build applications that leverage data, statistics, machine learning, but they need access to data, right? Which, doesn't really, it doesn't often occur in CSVs and spreadsheets and that type of stuff. You need access to production grade databases or Parquet files on S3 or whatever it may be, right? As your workflows get more and more complex, you require orchestration tools to be able to run them. You need data and the orchestration tools to be connected. You need versioning, right? You need to version code, data, and models. And once again, you need all of these things to be interacting with a local workstation. You require compute, such as cloud infrastructure, Kubernetes, whatever it may be, right? And then you need to be able to deploy things or integrate your machine learning and data science workflows into the pre-existing software stack. So to tell this entire story, to get all of this set up, is really what we're talking about. And so I'm going to show you how we do that with the Metaflow Sandbox, and I've included the link. David Thrower has a great question. How long will the sandbox be available? It's in perpetuity. It's always there. I think someone from Outerbounds can tell you, perhaps Eddie, if he's online, can tell you, let's say you make edits to it, how long all those edits will stay around. But this is something that we want to make sure is available in perpetuity. And so I'm sorry, give me 1 second. I'm just, YouTube is, yep, okay. Great. So what we see here is essentially a souped up version of VS Code. And this is an introduction to Metaflow set of lessons. We have a bit of context on the right. We have our scripts in the middle. We can also put notebooks there, which is super cool. And we have our terminal down the bottom. So this is a basic flow where we have 3 steps: a start step, an eat step, and an end step. We can click run flow. Essentially, that executes a terminal script, which command, sorry, which runs this flow, as you can see here. It's Python flow.py run, right? And something that I really dig as well is how we can we have a Metaflow UI, which allows us to, introspect, have a look at what's been happening, how long each steps took to run, that type of stuff, and gives us a DAG. And of course, this is a very simple one, but as they get more complex, that can be incredibly useful. In your own time, you all can go through this stuff for sure. The point isn't really to go through all of it now, but essentially to just give you a sense of the capabilities here. One thing you may not know about Metaflow is it versions everything, all artifacts that you would want. So when you assign instance variables such as self.x, you can pass them between steps. And so that allows you to track experiments and version data automatically. And using the UI and something called Metaflow cards, you're actually able to build pretty sophisticated experiment trackers. Metaflow also interoperates with weights and biases and comment and these types of things if you already use those experiment trackers. And just a quick note for anyone at Out of Bounds watching, we Paul in the chat. I can't diagnose this currently, but has a console.js error. So if somebody could respond there, that would be fantastic. What I do want to tell you about is about the parallel processing and monitoring. So of course, a lot of the time, if we have parallelizable training steps and that type of stuff, for example, we want to make that as easy as possible for data scientists to do. And there are several ways to do this, but using the for each construct is one of them. And we can, for example, have a list that we essentially for each parallelize over that list. For example, so this is kind of a whirlwind tour of some of the features. I think there are two more I want to show. And this really speaks to one of the most important things that our sandbox affords you to access cloud infrastructure. So what we're having here is, if we have a step that requires significant compute, I'm actually going to start running this. We can send that step alone up to the cloud, or up to any infrastructure that's been set up for us. And we do that by simply using, now, of course, infrastructurally, this needs to be set up by a platform engineer, or if you're using the Outerbounds platform, we do that for you. But as a data scientist, you don't need to worry about configuration files or setting up all the cloud infrastructure. All you need here to do is to use the @Kubernetes decorator, and that will send that step up there. You can also specify how much memory you want to provision, and all types of things there. And that's, as you can see here, what's happening with this step is that we're spinning it up and we're creating the container necessary. While that's happening, Hamel, maybe, I mean, I know you love this type of thing because you appreciate the challenges of for data scientists of working with Kubernetes, right?
Yeah, I mean, so like, yeah, just to reinforce, like, Metaflow is actually really easy to work with. You can do a lot of stuff. You can get started on your laptop. The Sandbox is really this like augmented documentation. This like makes it easy for you to learn stuff without any setup. And it's like this really rich tutorial where you can like run code and like read documents side by side, and kind of takes you through the tutorial. But then like, there's some more advanced concepts like scaling up, like using the cloud, things like that. And, you can experience that inside this sandbox. So I think it's cool. And of course, you don't need to write any YAML, which is great. You can just use Python, which I think is great to avail yourself of cloud resources, which I found very convenient and really good. Like the level of abstraction that Metaflow has is like really thoughtful. And I'll go through that more in I'll show some examples of that when I walk through the code.
Amazing.
When I go through the tutorial.
Thanks, man. And I showed the UI before, but this is a slightly more complex process, a DAG. So we can see that we've actually had our parallelization happening here as well, and we can see timeline and all of those types of things. And this is where we'd put the card, and we can see we have our clouds there. I don't think I'm going to click run, but depending how long this takes, yep. I just wanted to make clear, I mean, an obvious question we have that comes up now is, if we're running steps locally and then running steps on the cloud, what's the dependency management story? How do we even make sure we have the same packages installed on the cloud and locally, right? And we do that using Conda or pip. In this case, we're doing Conda, and we have a Conda decorator, which allows us to specify exactly what packages we want. And here we have some typical data scientist packages, such as Data Shader, Pandas, and PyArrow. Because this will take a few minutes to bootstrap the environment, I'm actually going to stop sharing my screen now, and you all can jump in and check that out. What I am going to do actually is link. So Hamel's about to get started with the natural language processing and MLOps tutorial. I'm going to link to that in the YouTube chat so you can follow along and code along. Now, it will actually open this is important. What I want you to do is click open in Sandbox. And maybe Hamel, you'll actually show this. That will actually spin up a different sandbox for you. And one reason that's necessary is that the sandbox I've just been running has a different set of dependencies than the natural language processing tutorial. Okay. So maybe without further ado, I'll stop sharing my screen, and Hamel, we can jump in for what we're here for. And I appreciate everyone having more patience with that before we jumped into the NLP stuff, but I think that set the scene for where we want to go now. So this is the link I've just shared in the chat. So take it away, Hamel.
Yeah, so okay, I'm just gonna walk through this natural language processing of Metaflow. And it's not really about NLP per se. I think like the thing to take away from this tutorial is like learn about Metaflow. It's not really, I'm not gonna really focus on trying to learn about NLP, because I think it's useful to try to learn something by walking through an example, and this one happens to be NLP. Like Metaflow, you can really, it's flexible to use really in any kind of problem. And so, this is just an interesting kind of example. That's a simple example that kind of allows you to learn some important concepts. So as Hugo said, so this is the page that you can go to. This is in the doc. So it's outerbounds.com/docs. And under that, you'll see tutorials. And then there's lots of different tutorials. And then there's natural language processing tutorial. Easy way to try it. I mean, of course, you can try to do some of these things locally, but I think if you're learning, it's good to just use the sandbox. So you click open sandbox. I already clicked this before to kind of get my sandbox warmed up, so you don't have to wait and watch my sandbox start. But when you click this, it'll take you through the same screen that you've seen before. And basically, so you want to start on this setup step. And you want to do this open sandbox, so you don't really have to worry about any of these things. And when you
but if you did want to run it locally, you could, right? But
you could, yeah, you could.
We don't want you doing that today. And on the warming the sandbox, actually, our wonderful colleagues at Outerbounds, they actually they pre-warmed a bunch of sandboxes for us today, so that people should be able to spin. Yeah,
okay,
yeah. So it was very good of them.
Oh, great. Okay. So basically, what you'll do is, so you'll be taken to this natural language processing tutorial. One thing you'll want to make sure is in your notebook, you want to make sure that's the right kernel. So it should say NLP beginner tutorial here. If you don't for some reason have that, then make sure it says that. And you might want to say select another kernel and then look for this NLP beginner tutorial. Sometimes that can happen. But there's a one-to-one correspondence really between the documentation and like this VS Code thing. So this is like a VS Code plugin. It's a really clever way of like having documentation. You could see these numbered sections 1 through 8, like understand the data, construct a model, set up a baseline flow, so on and so forth. You'll see like these are the same sections here. So I recommend like if you're doing this learning of Metaflow, you should kind of like look at the documentation. You should kind of have these windows side by side. I'm not going to open these windows side by side here because I want you to be able to see the screen. But I would actually, if I were you, just open the docs in the VS Code thing side by side. And so, okay, I'm just going to start running through this example. So this is like an NLP problem that we set up. It's a binary classification problem, probably like the easiest kind of problem that you can imagine in NLP. And essentially what we're going to do is we're going to do a sentiment classifier over this women's e-commerce clothing reviews data set. And, we're going to load the data set and we're going to fit a baseline model. And, the code is here on this document page, but we can go and look at it in the VS Code part.
And one thing I want to mention, you're showing something that we didn't have in the onboarding lesson. I had scripts and the terminal. This is a notebook, right?
Yeah. Yeah, I mean, maybe it's because I helped write this particular tutorial when I was working with you, Hugo, and so I'm very partial to notebooks. So perhaps this is maybe something that maybe some artifact of my preferences. I don't know, but this part is a notebook, and basically what we're doing is we just want to introduce you to the problem. So there's a data set. It's about 20,000 observations in this data set. Okay, like what is in the data set? So it's basically labels of 0 and 1, and then reviews. So pretty simple. It's like the task is to classify these reviews correctly as being positive or negative, 0 or 1. And what you always want to do with any machine learning problem is fit a baseline model. And you want to, one useful baseline model is just do the very naive thing, which is like a majority class classifier or a random classifier. In this case, I'm just having my baseline predictor be a positive review. So just predict 1 all the way across the whole data set. So that's what this line is doing, is just an array of 1s in the same shape as the validation set. It's like the same number of rows.
Mm.
And then basically it's just computing the accuracy and ROC score. If I use that dumb baseline, and you should see AUC of 0.5, 0.5 just means it's like random guessing, which is that means it's no better than random guessing, which in this case, that's what it would mean. And this is the baseline accuracy. And the reason why it's you want to be able, this is like the dumbest model you can possibly, this is not even a model. Like if you don't beat this, then you're doing something wrong. This is a very important step. Any kind of machine learning is to kind of don't use machine learning first and seeing what the baseline is, so that you can ground yourself in that.
Exactly, and see what lift machine learning brings, right?
Yeah. And like I would say, you probably want a better baseline than this, but you can get there over time. But you should definitely start with this as a sanity check, because this will help you check if you did something very wrong, and it's good to know. So this is the first thing. We understand the data in the problem, and so we have our baseline. We haven't made a model yet. And so the second step is to construct a model. So I'm going to head back to the documentation here. And there's some documentation here. I'm going to show you a bit about this, so we don't have to. We're gonna import a model, and we're going to train a model. So let's go ahead and do that. So I'm going to import this and neural bag of words model from this model.
And is this using TensorFlow or?
Yeah, so let's look at it. So what is model? So actually, model is this custom thing that we have defined. And you kind of want to do this a lot of times in your flows. It's good to have like separate, scripts. And so this is what the model module looks like. It's just a wrapper around Keras. It's a very simple Keras model that just is a couple of dense layers. It's really like, it's really a couple of dense layers, and it's just doing neural back of words. So nothing, it's kind of like the simplest sort of NLP model that you can use, that you can have with TensorFlow. And we're just like using a count vectorizer as the features. We're not even using embedding here. We're just doing something very simple. And the idea is like to keep the model simple so it runs fast, so that you can focus on Metaflow and not focus on machine learning. So if you're wondering why we have such a simple thing, well, that's really why, because we want to show you Metaflow. So this is the model. It just has like this init. You can specify vocab size. Everything else is pretty much hard-coded here about the model. And then there's a fit. And then that just calls fit for you. And then there's predict. And there's some convenience methods for like getting the evaluation metrics like accuracy and ROC. And these are some things to help you load and save the model. So going back to that, I'm gonna click on this Metaflow icon here. I'm gonna go back to construct a model. You have to click on this thing again to escape back out of the file view. And we can just fit the model. So this is just going to read in the training. We've already segmented the training set out to make this easy. So, we have this vocab size of 750, just the dimensionality of the features that we want to create from the NLP dataset. So we can go ahead and fit that. Okay, it's asking me to select a kernel. I want to use this NLP kernel. And it's going to go and fit. Should be pretty fast. Because again, it's a pretty small model and we're not trying to train the world's biggest model here. Because again, the idea is to learn things about Metaflow. And then this is kind of, this is a baseline model. And so using the same kind of metrics that we've shown before, we have the baseline accuracy and AUC. So just training it a little bit. So the idea is before you get into Metaflow and stuff like that, it's good to have an idea of what you want to accomplish. And just make sure the plumbing works. Like you're able to train some model, even a small model that beats your dumb baseline. And then so it's working, and then you can iterate on it a bit more. So that's what we're showing here really is, okay, this is a dumb model. We have a baseline. You have this new baseline with this dumb model that we have. It's a very simple neural bag of words model. And then you can see the baseline is a bit higher, 0.911 and 0.868 compared to the 0.5 AUC and the lower accuracy of the other one. So, okay. So that's all non-Metaflow. This kind of simulates what you would do as a data scientist. Then you say, okay, well, I want to now productionize this workflow and sort of move beyond sort of this ad hoc thing. And so you might want to do that with something like Metaflow. And I really like Metaflow. And so I'm going to show you a kind of moving from this to a basic flow. And then we're going to keep adding to the flow and show you more and more concepts. So the first thing we're going to do is set up a baseline flow. The baseline flow is the next step in this. And the baseline flow just has 3 parts: the start step, and the baseline step, and the end step. Now, all flows have a minimum of 2 steps. All flows have to have a start step and an end step. So you could just make this flow start and end, but I'm just, for illustrative purposes, I'm showing that this third step. So I'm going to click on this set up a baseline flow. And basically what you have here is the same thing that we had in the notebook, really, but we're just putting it in Metaflow. Okay, so you're reading in the training data set, you're reading in the validation data set in this Parquet. You're emitting, some things to the logs. And now I want to call, okay, so this is a baseline flow. The way it works is Metaflow is this class-based thing. You define your DAGs in a class and you subclass a flow spec. And then you always have a start and end step. And you may have some middle steps. You could name this middle step whatever you like if you do have a middle step. And you decorate the steps with the step decorator. And there's a lot of different decorators in Metaflow. But step is one of the central ones. And so the first thing, so you
the other
notice
thing that I'll add
pipe.
there, and this is, I think, this may be obvious to a lot of people, but this is one of the things that I love about Metaflow is the code that you use to prototype in the notebook. You kind of just put in this flow, like you have to add self dot in order to pass it between steps and that type of stuff. But once again, you're not writing configuration, YAML, anything along those lines. You're writing pure Python, and it's pretty close to the code you've already written. So there's not a huge cognitive load or lift in turning it from a notebook to a flow.
Yeah, so I want to point out a couple of things. So let's zoom in and let's reflect on some of the syntax, actually. So you notice that, let's think about this start set. So the thing I think that's really neat is you notice how I am setting a class variable. This data frame, I'm setting it as a class variable using self.df and assigning it to that. Same thing with the validation set. So what's interesting is that's a pattern that you use in Python. That's nothing, that's like if you want to save some data in Python into a class, you know that you need to, save it into this class variable. And so what happens is Metaflow kind of overloads that. And it does something interesting is like when you do save data in this way, like this, Metaflow will automatically snapshot that variable and version that variable for you. So what's really neat about that, and this is kind of throughout this design of Metaflow, is there's really low cognitive load because it kind of bootstraps on what Python already does. Like you don't really have to memorize. Oh, how do I save a data again in my machine learning workflow? Like once you see this, once you see like, oh, self.df, whatever, it kind of sticks with you. Like you don't really have to look at documentation after this. And that's neat because like it's meant to be super Pythonic. And then the self.next, this thing is calling the next step. So you have to specify what the next step is. And same thing here, you specify what the next step is, so on and so forth. And then you, like I said, you need a start and end step. And you see like what ends up happening is all of these artifacts, all of these pieces of data become artifacts and are permanently like archived in a snapshot for you in version. And so in addition to that, this is how you pass data in between steps. So like you notice the validation set is kind of referenced here. And this is like overloading, in a sense, what you already used to from Python. Of course, if you're going to reference data in another method of a class, then you can just do that with, self dot. And this kind of extends that thinking and says like, okay, if you have another step in your DAG, you can just use self dot. And again, you don't have to memorize this because once you see it once, then you kind of know. And that's like, it's really built into the design. And there's so many things throughout the design of Metaflow that are like this, where it kind of sticks with you when you see it the first time and you kind of immediately get it. And yeah, that's how it works. And so the way you do it is you define this class in this way. And this is a very simple, like linear flow, where we have, okay, this flow is getting some data. This flow is looking at evaluating or computing the baseline, not with a model, but with the kind of naive method with this majority class classifier, and then just printing something. So let's go ahead and run the flow. And like when I click this button, run flow, it's just going to, it's important to pay attention to what's printed on the terminal here, because that's how you would, it's a CLI based thing. So and Metaflow is CLI based. And so what happens is, actually, let me make the terminal bigger so you can see exactly what happened. So you would say, Python baseflow.py run, and that would do the same thing. So you're just doing baseflow, Python baseflow py.run, and it does that. And we could do that on the command line if we wanted to. So, let me get this thing out of the way. So if I need to allow, okay, there we go. I could go into there and I could say Python baseflow py run, and it would do the same thing.
Awesome.
So you might want to do that. I would suggest actually running in the terminal, because like if you're using Metaflow, you're not going to have this run flow button, and maybe it's good to get that muscle memory. But either way, like look at the terminal, see what it's doing. So it is like good to like stop and look at the terminal actually. So like what is in the terminal? Okay, like let's like reflect on this. So okay, when you run the flow, you see I ran the flow here. And first what happens is it does pylint. It just makes sure like this is valid Python. Like if you have something weird here, like I don't know, blah, like something that doesn't make sense in Python, something like that, it's going to tell you, hey, like you made a mistake. So that's just like to, make your life easier. So it says pylint is happy. And then it starts its process. So it's a, this is where it gives you all this rich output, workflow starting. And then what you see is like task sort of status, like task is starting and its task is finished. And then you might get things like here, these are just logs that you have printed. So, here you printed number of rows and you're getting that. And the thing that's interesting is these all mean something. So this is a step. This is a step ID here. This is a PID. And this can be used to kind of inspect these tasks and inspect the process and do all this stuff. So it all means something. It's all very useful. And the idea is like, these are kind of all running independently. These are like nodes in a DAG. And this is very powerful information actually later on, and we can discuss, I'll show you why. So, okay, that's enough. That's like kind of like intro sort of in a way to Metaflow. Now let's talk about the next step is like training the model. So this is just kind of the same dumb baseline flow where we just use ones as a prediction. And then like, let's go to training the model. So in this, I'm going to step up the flow a little bit, the complexity of the flow. Instead of a linear flow, I'm going to do a branching flow. What that means is I'm going to do kind of 2 steps in parallel at the same time. And then, in my DAG. So, it's useful to see different DAG patterns to like drive home the notion that you can have arbitrary DAGs, the shapes of DAGs. And so we're going to do these 2 steps at the same time. We're going to compute the baseline. We're going to train our model. And anytime you have these parallel branching flows or branching nodes in your DAG, you have to have a join step. And the reason we need a join step is you need to resolve any kind of duplication that you might have here in these 2 steps. And you need to say, okay, like if these 2 steps have the same data or the same variable, you need to resolve which one is promoted further, for example. And so, let's go look at that. So let's go to train your model. So this is the same exact thing as before, except we're adding this kind of like parallel step. And there's nothing too crazy about adding the parallel step. The only thing that's really different is in self next, you can pass a list of steps. So you're saying, okay, the next step is actually 2 steps in parallel. The one is the baseline step, which you already seen before. And this next one is the train step. And that's really the same thing that you've seen before in the notebook, where we train this like very simple model. And then what we do is we have this join step. And the join step, basically, you kind of look at the baseline and you say, okay, you look at where you want to grab the inputs from. So you have like this data is flowing through the model, like this val df, is actually passed through to the baseline, and it's also passed to this train step, or the training set is also passed through this train step. So like you just have to specify in Metaflow where do you want the data to be saved from. So I'm saying, all this does is says, okay, I want you to save a variable train df, but it needs to come from the train step. And there's a df variable in train step. So like in this train step, there's a df variable here, for example, self.df, and the self.df is coming through here. So you just need to resolve the data flow to like one of this branching steps, if that makes sense. So these are all the things I want to, yeah, thank you. It can be a little bit confusing to reason about that. Actually, like, it's helpful to look at pictures. So like in the Metaflow docs, if you go to Metaflow docs and you search for that, and you go to branching, and you look at this, it's actually a really good explanation about this topic. Every branch must be joined. The join, and it tells you why, and it talks about data, and you can read about data flow. I don't want to go into that. You should go read it, because like it's like more clarifying than what I explained, probably. So, okay, so that's what the join step does. And basically what I'm doing something somewhat important in this join step is I'm collecting both the baseline and the model. I'm collecting both the model's accuracy and the baseline accuracy. Because again, I'm joining those two steps. So this step like kind of collects that together. I'm not doing anything with the information yet. I'm just like presenting it. I'm just basically printing it. So, I have a step that does the baseline accuracy in ROC, and then also the model's accuracy in ROC. And I'm just printing that here.
Awesome.
So let's do that.
Yeah, let's run it. Great.
Yeah, so this is doing that, and it's, you can see.
You can watch the epics or epochs, depending on who you are and how you say it, roll on in.
Yeah. And this is all very thoughtfully designed. Like I believe like this first number is like a flow ID maybe of some kind. This is the step name. This is, I think there's like a step ID here. Then there's a process ID, and all of these things can be referenced. And
they're all versioned as well.
Yes. And so, okay, like this is how that looks. So, okay, that's great. Now let's kind of infuse a little bit, like let's go a step further and let's actually evaluate your model. So there's no point like doing this. There's no point having a baseline if it doesn't have any teeth. Like right now, you know what your baseline is, but it's not doing any work. You're just printing it. But that doesn't do any good because you need to gate your model. You need to do some amount of checking. So like, okay, how would you do that? So let's go to this evaluate model step. And that's this step here. We're going to keep the same flow, but we're just going to add a bit more into the join. Okay, so let's look at that. So this is really the same thing. This evaluate model is the same start step, same baseline, same train set, almost the same join step, except, it is the same join step, but the end step, instead of just like ending, let me remind you, the end step here was just nothing. It just said flow is complete. In this one, I'm adding to the end step. And what I'm doing is saying, okay, I'm doing a couple of different tests. I'm doing kind of a smoke test. A smoke test is a good idea when you're doing machine learning. It's like give your model, construct some examples where your model must like be correct at. And if it's not correct at that, then you want to like kind of take a step back. And it's a good idea to do that just to kind of help you catch regressions and like errors that might happen. So in this case, in this end step, basically what I have is kind of like different kinds of checks. One is make sure it beats the baseline. So the model's ROC should be better than the random ROC when you just predict ones, where you just predict positives. So this is like one way. This is going to be a Boolean if this kind of simple test passes. That's one thing. And this is just printing that out. And then this is kind of a smoke test. These are two very like easy examples. Poor fit, and it's baggy in places where it's supposed to be. And this one says, I love it, very high quality. So this should be a positive example. This is obviously a negative example. And we're asking the model to predict against these two things and making sure that it's the correct class. Like the negative is negative and the positive one is positive. So, less than 0.5 is greater than 0.5. And then, we also want to know if it passed the smoke test. So, having smoke tests and having beating some kind of baseline, you might want to even make this more rigorous. Like in my experience, I'm not just made it better than the baseline. I made it better than the baseline, plus like some epsilon or something like that. But you don't have to do that here. I just want to say like you can think about this better. This is just like a concept that you can use. And then what we have here is sort of this check. And there's something called tag. So you can tag your run. So tagging is like a really interesting concept. So every flow also has runs. So you can run any flow many times, and then you can tag those runs. So in this case, if I determine that this flow has passed all these tests, like the baseline test and the smoke test, I tag it as a deployment candidate. And that helps me kind of, you can use that downstream in other systems. You can use it in your review process to like figure out what things are the deployment candidate and focus on those. You can use it as a gating criteria to say, hey, this thing is not going to the next stage if it's not a deployment candidate. You can get fancy with this. This is kind of like a very simple example, but that gives you an idea. So, okay, let's go ahead and run it. And I'll show you how to get these tags. So you'll see like there'll be these steps, this baseline and train. They're actually, notice how they're running in parallel. You can see that because like you can see it kind of interleave these logs. You see how it's saying baseline, train, and baseline again. That's because baseline and train are happening in parallel. That's why these logs are
and you can see
interleaved
it says task is starting for both before one of them finishes as well, right? So
yes, that's right. Yeah.
Yep.
Yeah. So this is also cool. That task is starting like that.
Yep.
They're both starting at the same time. And so yeah. And so like all of these things are printed. And I like to, one pro tip is like save interesting, save stuff. Like it is useful to just reference the flow and know if it meets the baseline. It is useful to reference the flow later and say, did it pass the smoke test? Those are good to know. Okay, and we'll use those. Okay, great.
Absolutely.
So this is the flow. Next thing is, so that's like basically your flow. You kind of learn a couple of things. You learned about branching, you learned about saving artifacts, you learned some design pattern of how to evaluate models and gate models. I think, a lot of people forget, like, yeah, you should definitely gate models. Don't just print the like accuracy and stuff to the logs and that's it. No, you have to do something with that. You should use your baseline and kind of use it to do something, give it teeth. So it has some influence on your process. I think a lot of people skip that. So, okay, so that's kind of like a bit about flows. We'll come back to another flow in a bit. But okay, so like Metaflow has like a great Python client that you can use to like inspect these flows. And it's really useful, like if you want to, you can like build all types of stuff on Metaflow. Like you can use this Python client to like query Metaflow about the runs and get all various artifacts of those runs, do all kinds of things in runs. It's actually really cool. And so I'll show you a little bit about that now. So this is a notebook about how to use your model in Python.
I'll just add here that, we've started in notebooks to do exploratory data analysis and develop, first models and baselines and that type of stuff. Then we've started scripting and using the command line to run those scripts to develop more production grade software. And now we've run some flows, we're jumping back into a notebook. And so, to analyze the models we built and that type of stuff. So that really speaks to the iterative approach here, which I think is important to note. I realize we've come up against the hour. So if people need to dash off, that's totally cool. We'll probably take another 10 minutes or so, but I just wanted to paste a link to our Slack if you wanted to come and chat about any of these things as well. So I just wanted to add that. But yeah, Hamel, let's jump in and see. I love the Metaflow client API. So
yeah, so this is great. So what this is doing is saying, hey, I want to get all the flows that have a certain tag. Now we're going to use that tag that we created. And then we also an additional check to make sure the run is successful. Like there's no errors in the runs that ran successfully. Okay. And so this is a little function I created, and let's go ahead and run it. This is just going to get the latest successful run. So so it's NLP flow is the name of the flow. And that was, if you recall, just to let you know, it was called NLP flow, okay? And deployment candidate was the name of the tag. Again, if I go back to this, remember the name of the tag that we had here is deployment candidate. And so that's where these two arguments come from. This gets the run. And then we have, got an error. Okay, so that's interesting. That's because I didn't run that cell, sorry. So yeah, so then you have the run, and then from any run, you can get any artifact you want. So run.data gives you model artifacts. Actually, like I could show you a bit. So if you do run.data, you can see different artifacts. Actually, it doesn't show up here, sorry. But basically, the model dict will show up. And the data will contain all your model artifacts. So if you go into, let me go back here. And you see how model dict is actually one of the things that are saved up here. This is getting the model dict. And going back to the notebook with a model dict, that kind of allows you to load the model. So this is my model has a from dict method that allows you to load the model. This is a good way to load a model, by the way. And yeah, and then you can make predictions with the model. So this is just showing using that model, calling the predict method, and then saving that to a Parquet file. You can do predictions in Parquet file. Now, so kind of similarly, you can take this notebook, what I did right now, like getting the latest model and loading the model, making predictions in file. You can just put that in a flow. So that's what we're doing here. This is where you're going to do batch predictions. So essentially what we did in this notebook is we made batch predictions. And so like if you made that into a flow, it will look like this. These are parameters that you can have in Metaflow. This just allows you to have more rich command line arguments. Like if you wanted to pass parameters in the current command line arguments into your flow, you can do that. And so basically this is that getting the successful run thing.
Maybe I'll just add here that once you've built flows, generally you'll want to either do batch predictions or have a real-time endpoint. So, and this is what these two kind of lessons are teaching now. Lesson 7 is, as Hamel's going through now, is batch prediction, because you want to make your results useful, right? And your machine learning work useful.
Yes.
So, two common ways, just to reiterate, are batch predictions or real-time endpoints.
Yeah, that's right. Yeah, and so basically, this is like a parameter you can pass. The default is this Parquet file, but you can pass a different Parquet file. And, you have your start method. This is going to get the latest successful run. And then this is going to go through the kind of similar thing you saw in the notebook, where it's going to make predictions against a new data set, calling it predict Parquet. But you can just kind of pretend that, okay, you have a Parquet file, maybe you run a query first or do something like that against it, like a new data set or a new partition of a table that you might have. And then you make predictions. And this is kind of an illustration of like, okay, one way you could do batch prediction is like write out to a Parquet file. And you can imagine, Metaflow is very agnostic. Again, it's just Python code. You have to think about what works for you. Like when you're making batch predictions, like let's say you want to write your batch predictions out to a database. You might want a Hive-backed, Parquet-backed Hive table or something. And like in this case, that might be useful for you to like write out your predictions to Parquet in the right way, into the right path, in the right location, so that it gets loaded into your table the way you want, and things like that. So like the sky's the limit in like how you can do this, but this is a very simple example. So that's really how it works. The new kind of thing here is the sort of this parameter. And I can show you a bit about that as well. And I can show you kind of something neat after this is done. So we're running the flow, and it's just going to do this batch, make these kind of batch predictions, and save it, save the batch predictions to whatever I passed in as a parameter. And it even tells me sort of where this is here. But one thing I really like is if I do the same thing, if I do Python, and this is called predflow.py, and if I do run help like this, it tells me sort of what is there, and it tells me this thing, this URI flag. And where does this come from? This actually comes from here. So the parameter is URI, and where to park your predictions for other apps to consume. That's exactly what this variable is. It actually comes from this. So you could, in theory, you could say Python predict flow run. You could say -- URI, and just for fun, I can just pass in the same thing, and it would work the same way. And that's what that means. And I think it's cool. The cool part is like you could just do help, and it just like kind of like this like CLI tool that just kind of like everything is made into this nice CLI tool that you can sort of get into. And you can see there's other options here for sure. I actually like recommend like using help a lot when you're running Metaflow. I think it's important to actually use the CLI, run help. You can even before, you can say like help here, like before the run, and you can see all the different commands. Like one is run. It's actually useful to like go through all of these things, like when you're curious, and just kind of like, oh, that's cool. What's interesting? What does tag do? That's cool. What does show do? There's all kinds of cool stuff here. You should like check it out. And like the help actually works at every level. So like if you want to know what a command does, like if I want to know, okay, what does tag do? I can just do help on tag and like get even more commands for that. Cool. So like, I don't know, it's like pretty interesting.
Yeah.
So yeah, it's like a first class like CLI experience, I would say, in that sense. Okay, so anyways, that's how you make that batch prediction thing into a flow. So like as Hugo said, okay, what if you wanted to have a real-time endpoint? Again, like Metaflow is very agnostic in like your infrastructure. It's meant to like be, you can do whatever you want. So like a good design pattern is like if you have some other real-time serving infrastructure, maybe you can just read that artifact that you want from Metaflow using the Python client. And that's basically what this is kind of trying to drive home. This last part is like, this is fast API. And we are, this is just showing, okay, like if you wanted to grab the model and run it, it would do that. Actually, this is like what I'm showing here is the making a request to the model.
Yep.
But actually, let's look at the actual the model server, because I think that's probably more interesting.
Exactly.
So this is a situation where okay, I'm getting the model in the same way I showed before. Remember the latest successful run thing with its 2 arguments. You're doing the same thing, creating this. This is the fast API server, and I have this endpoint sentiment where you're saying is it a positive or negative review. And that's all it is. So it's just to drive home, like you can place, it's easy to build whatever you want on top of interoperate with Metaflow. This is like you're interoperating with Metaflow with fast, the fast API. And yeah, you could do this any way you want. Like you could also, one technique is like, this is like a toy example, but one thing that I might do is I might save my model artifact into the right directory if I'm using something like NVIDIA Triton server, for example. If you have like a model serving instance like that, if you're using NVIDIA Triton or TorchServe or anything like that, you save your model into the right directory with the right config files. But this is like, you do something similar. You might use the Metaflow Python client like we're doing here. So this is the server. This will start kind of in the background. The way we'll start this server is actually with this command. So this is like the name of the Python module, and we just can call it like this. So we'll do that. So I'm just gonna paste it right here. Oops. Was I not copy and pasting correctly? Copy. See if that works. Okay, I guess my clipboard is not. I'll just type it. What about that?
Sounds good.
Okay, cool. So that starts the server. And then basically we have this request file that we were showing here. Let me go back to that. So this is the request file. This is basically using the request. You could use curl if you wanted to, but like just for Python's sakes, you know, you could see that this thing is serving on that port. Actually, I don't know if it shows. Yeah, it says that it's serving on this port here. It's also here. You can see it on this documentation, and this will actually hit that endpoint with some sample values. So we can just do that here.
And you can see the default in line if you scroll up in requests.py. The default in line 7, is this is my new favorite.
Oh yeah, this is my favorite brand.
Yeah.
Yeah. So
you want to open another terminal? Yeah, exactly.
Yeah.
And just everyone watching, he did that by clicking the plus.
What's a negative review of something?
Well, let's just do the default to make sure that it returns positive.
Okay, let's do the default. Okay. Oops. See, look at that. I like the error.
Yeah.
Good job, whoever. It goes to Eddie. Okay, so
great. Okay,
yeah.
that's
I guess this is just fast API stuff. I haven't seen that. Fast API is great. Is how it does that. Okay, so what do you want to say? Hugo, tell me.
What about the? Oh yeah, great.
Oh well, then,
okay. So the model, yeah,
maybe hot dogs. Something positive about hot dogs.
Yeah, and it could be like, I don't know. Do you say like surfers in Australia say sick? Like that's cool, like as well. So I don't know. Pick.
Okay, so we have some work to do on the model, maybe. I don't know.
Yeah, exactly.
We can. It's like real machine learning.
Yeah,
doesn't work
totally
perfectly. So that's great. Okay, so and this is not like a review. I mean, I don't know. I am upset because the clothes don't fit very well. There you go. Okay. It's more in line with the distribution of the data, like something about fashion. So,
absolutely.
Anyways, yeah. So that's like kind of you can think about it. Yeah.
Great,
I mean, so yeah, I hope you learned something about Metaflow and kind of, how to use it. There's a lot more to Metaflow than that. We just touched on the surface, but I hope it gives you excited enough to like give it a go.
For sure. And if you want to, as we've given links to our Sandbox, to our tutorials, check out other live coding sessions we've had on our YouTube channel for recommender systems, and among other things. But I mean, I learned a lot about how you think about Metaflow as well and what you value in it, Hamel. So I really, really appreciate that also, and appreciate your time as always. I do, if people want to chat about this type of stuff, please do join us on Slack. And I'm once again going to paste that link into the YouTube chat. I also want to thank everyone for sticking around. I realized we went, 15 minutes over, but, it was too exciting to show how to use these models for batch predictions and real-time endpoints in the Sandbox. So I'm glad we did that. I also, as I said, we've got a fireside chat coming up with Federico Bianchi from Stanford about moving beyond proof of concepts with large language models, and how to incorporate them into your software stack and show real business value and build defensible moats with LLMs. So, and I put a link to that in the chat. So please do sign up for that. I'd like to thank you all once again for joining and sticking around. But most of all, thank you once again, Hamel, for your time, expertise, and just generally good vibes.
All right, sounds great. Thank you.
Awesome. And